In my previous video, we have seen how to examine and measure in magnitude and direction correlation between two variables x and y. In this video, we are going to talk about regression, which is to estimate the value of one variable when that of the other variable is known. Hello friends, you are watching YouTube channel Number Collage. This channel features videos on mathematical concepts. Effort has been made to explore the concepts through basic mathematical ideas. Hope you will like my effort. Suppose we are given following pairs of values of x and y: 1, 5, 2, 6, 3, 5, so on and so forth. We have to plot these points on a graph paper. Let us plot them. First point 1, 5 will be 1, 5, 2, 6, 3, 5, 4, 6, and finally 10, 9. Here the points are seen to lie in a narrow strip. Hence we say that variables x and y are correlated. Once the correlation between the variables is established, next we have to estimate the value of one variable when that of the other is known. This is achieved by the analysis of regression. So in this video we are going to talk about regression, which is a method of estimating the value of one variable when the value of the other variable is known. In this graph, the plotted points are seen to lie in a narrow strip. If the strip is nearly straight, we may draw a line such that all the points are close to it from both sides. Such a line can be taken as the representation of the ideal variation. It is called the line of best fit. It is a line such that the sum of the distances of the points from the line is minimum. Hence it is called the line of regression. We have to draw two lines of regression. The first being line of regression of y on x. In this, we minimize the deviations of the points from the line vertically along the y-axis to get a line called the line of regression of y on x. Equation of this line is written as y equals a plus bx, and it is used to estimate the value of y for a given value of x. The second is line of regression of x on y. In this, we minimize the deviations of the points from the line horizontally along the x-axis to get a line called the line of regression of x on y. Its equation is written as x equals a plus by, and it is used to estimate x for a given value of y. We will study method of least square, which is a method of obtaining lines of regression. In a xy coordinate system, let y equals a plus bx be the equation of the line required. P xi comma yi be any point not lying on the line y equals a plus bx. To find the line of regression of y on x, we minimize the sum of absolute distances of the points like p xi comma yi from this line, which is measured along the y-axis. So we draw a vertical line from point P on the line which cuts the line at point Q corresponding to point P xi comma yi. Here yi will be the point on y-axis. X coordinate of point Q will be xi, and since the point lies on the line y equals a plus bx, its y coordinate will be, from this equation, a plus bxi. That gives us a point on the y-axis, a plus bxi here. Now the absolute distance mod pq will be mod of this yi minus this a minus bxi. Since distance is always positive, for minimizing mod pq bar, we will minimize its square. we will denote the sum of the squares of these distances as s and write s equals summation fi into square of yi minus a minus bxi, where this fi is the frequency of points xi comma yi. Now we have to find a and b such that s is minimum, and the conditions for its minima are partial derivative of s with respect to a dou s by dou a equals 0, and partial derivative of s with respect to b dou s by dou b equals 0. Now we have s is equal to summation fi into yi minus a minus bxi whole square. So dou s by dou a will be 2 summation fi into yi minus a minus bxi multiplied by derivative of minus a with respect to a is minus 1 equals 0, and dou s by dou b will be 2 summation fi into yi minus a minus bxi into derivative of minus bxi with respect to b will be minus xi equals 0. So dividing by minus 2, we write this as summation fi into yi minus a minus bxi equals 0, and dividing by minus 2, here we get summation fi xi into yi minus a minus bxi equals 0. Expanding this further, we get summation fi yi minus a times summation fi minus b times summation fi xi equals 0, and summation fi xi yi minus a times summation fi xi minus b times summation fi xi squared equals 0. Here we require summation fi yi, summation fi, summation fi xi, summation fi xi yi, summation fi xi, and summation fi xi square. If all these required sums are known, by solving these two equations 1 and 2 simultaneously, we can find values of a and b. In particular, if all the values occur only once, that is, if fi is 1 for all the i's, then the above equations take the form summation fi yi will become summation y equals a times summation fi will be n, which is the sum of frequencies, plus b times summation fi xi will become summation x, and this summation fi xi by I will become summation xy equals a times this will be summation x plus b times this will be summation x square. These two equations can be solved simultaneously to find the values of a and b. From this we can deduce the line of regression of x on y, as from this first equation we write summation x equals a times n plus b times summation y, and summation xy equals a times summation y plus b times summation y square. From these two equations we can find the values of a and b. These equations are called normal equations. We are given a pair of values of x and y, and from these values we have to find the equations of lines of regression. First we will prepare a table of values of x, x square, y, y square, and xy. Values of x values of y, values of x square, values of y square, values of xy will be, and the serial number will be. Now we will write sum of frequency or 5 serial numbers. Sum of x 35, sum of x square 255, sum of y 25, sum of y square 145, sum of xy 189. Now the equation of line of regression of y on x is y equals a plus bx, where a and b are given by normal equations summation y equals an plus b summation x. We name this equation 1, and summation xy equals a summation x plus b summation x square. We name this equation 2. Here summation x is 35, summation x square is 255, summation y is 25, summation y square is 145, and summation xy is 189. Now we will substitute these values in these normal equations and prepare two simultaneous equations. From first, we write 25 equals 5a plus 35b, and from this second we write 189 equals 35a plus 255b. In order to solve these two equations, we will multiply this first equation by 7 to make the coefficient of a equal, that is 35. So the first equation becomes 175 equals 35a plus 245b, and we write the second equation as it is, 189 equals 35a plus 255b. After that we will subtract second equation from the first, so we will change the signs. Minus 14 equals 0, minus 10b, that gives b equals 14 upon 10, that is 1.4. In order to find the value of b, we will substitute this value of b in the first equation and write 25 equals 5a plus 35 into 1.4, that will be 5a plus 49. That gives 5a equals minus 24, or a equals minus 4.8. Now by using the values of a minus 4.8 and that of b 1.4, we write the equation of line of regression of y on x as, from this, y equals minus 4.8 plus 1.4x. So this is the line of regression of y on x. We have found the equation of line of regression of y on x as y equals minus 4.8 plus 1.4x. Now we will find out line of regression of x on y. For this, the linear equation will be x equals a plus by, where a and b are given by normal equations summation x equals an plus b summation y. We name this equation 1, and summation xy equals a summation y plus b summation y square. We name this equation 2. After substituting the values from here, we get equation first as 35 equals 5a plus 25b. From the second equation, 189 equals 25a plus 145b. We will multiply this equation by 5 to make the coefficients of a same, that is 25. So it will be 175 equals 25a plus 125b. We will write the second equation as it is, 189 equals 25a plus 145b. After this, we will change the signs of the second equation. This will be minus 14 equals 0, minus 20b. So this gives b equals 14 upon 20, that is 7 by 10, that is 0.7. We will use this value of b in this equation and write 35 equals 5a plus 25 into 0.7. That will be 5a plus 17.5. That will be 5a equals 35 minus 17.5, 17.5. That gives a equals 17.5 upon 5. That is 5 3s are 15, 5 5s are 25. That is a equals 3.5. Now we will substitute the values of a 3.5 and b 0.7 here and write equation of line of regression of x on y as x equals 3.5 plus 0.7 y. So we have line of regression of y on x as y equals minus 4.8 plus 1.4 x, and line of regression of x on y x equals 3.5 plus 0.7 y. Now we will see what it all means. We are given following data of pair of values of x and y. Values of x, values of y. We will plot these points on a xy coordinate system. First 5 2, 6 4, 7 5, 8 6, 9 8. We will also plot a line of regression of y on x, y equals minus 4.8 plus 1.4x. For x equals 0, y will be minus 4.8, and for y equals 0, x will be 3.43 in this equation. So we will plot these 2 points on the axis and draw the line. So 3.43 somewhere here, minus 4.8 somewhere here. A straight line through these 2 points will be this line, which best fits these plotted points. Secondly, we have a line of regression of x on y, x equals 3.5 plus 0.7 y. When x equals 0, y is minus 5, and when y equals 0, x is 3.5 in this equation. We will plot these 2 points on the axis and draw the line of regression of x on y. So 0 minus 5 will be here, and 3.5 comma 0 will be somewhere here, and a line passing through these 2 points will be this, almost same as the line of regression of y on x. This line also best fits the given pairs of values of x and y. So as mentioned earlier, lines of regression best represent given pairs of values of x and y. Friends, if you like this video, please click the like button. Share this video with your classmates. Don't forget to subscribe this channel. Make constructive comments to help improve my videos. See you in the next video. Until then, keep watching Number Collage. Thank you.